In today's note, we're going to be looking at the surface area of 3D shapes. So before we begin, what is surface area? And surface area is the number of square units needed to cover the surface of a 3D object. So in other words, if we're looking at a 3D object, we're trying to find the area of all the faces. So if we look at the first shape, we have a cylinder. And if you want, you can go and you can reference the formula sheet again, the same one that we've been using in area and volume and perimeter. And again, next to volume, it does have the formula for the surface area, or it breaks it down. But if we want to find the surface area of this cylinder, we need to find basically the area of two circles plus the area of a rectangle, which is basically this lateral surface. So if I was to break up this shape, I would have two circles and a rectangle that kind of connects the two. So going to my formula sheet, it's going to be 2 times the area of a circle is pi r squared plus a rectangle, which is length times width. However, if we continue down, pi r squared, I don't have a length and width for my rectangle. I do have one part, we can say the width, which is 12, or the height of our cylinder, but I don't have the width. And where we get the width from, and again, you can tell this by looking at the actual formula sheet, but where we get the width from is basically this entire width here goes around the entire part of our circle when they're joined. And that entire distance around the circle is the circumference. So instead of having the length, I could say it's 2 pi r, which is the circumference, and instead of width, I could say it's the height, which is the height of my cylinder. So again, we can get that straight from the formula sheet, or we can kind of reason through it here. So plugging in all my information, 2 times 3.14 times the radius, which is half the diameter. So in this case, the radius is 4. So 3.14 times 4 squared plus 2 times 3.14 times 4 times 12. And now we're just going through and simplifying. So we go through and simplify the first part. We get 100.48 plus, and then the second part, 301.44. In the end, we get 401.92 inches squared, because we're dealing with inches. And that's the surface area of this cylinder. Moving on to the next shape, the cone. Again, looking at our formula sheet, the surface area is equal to pi r s plus pi r squared. Pi r squared is basically referring to the circle on the bottom. And for the upper part, if I were to break this apart, basically I have a shape that looks like that, or that shape is basically pi r s. So that's the formula for the area of that shape. So in order to solve, I do need one piece of information that's not given to me. The one piece of information that's not given to me is this dimension here, which is the slant height, or that S. So in order to solve for that, first what I need to do is figure out this slant height, which will tell me the S in part of my formula. In this case then, I should see a right angle triangle in my cone, the radius of 4, the height of 20, and I can use my Pythagorean theorem to find this measurement. So a squared plus b squared equals s squared, 20 squared plus 4 squared equals s squared, 400 plus 16 equals s squared, 416 equals x squared, or the square root of 416 equals s. And in the end, we get that s is equal to 20.396. So now that I have that slant height, I can use my formula, because 3.14 times the radius, which is 4, times the slant height, which is 20.396, plus 3.14 times the radius squared, or times 4 squared. When we simplify, 256.174 plus 50.24 equals 306.4 feet squared, which is the surface area of our cone. So we did have to do a separate calculation to get one more measurement, but then from there we're just plugging it into the formula for the surface area of our cone. In the next question, looking at the sphere, we want to determine the radius of a sphere that has a surface area of 452.4 centimeters squared. So we're looking for the radius, and we're told what the surface area is. So if I look at my formula sheet, the surface area of a sphere is 4 pi r squared. I don't know what my radius is, but I do know my surface area, so I can fill that in or substitute that in. So 452.4 is my surface area. 4 stays the same. Pi I can replace with 3.14, and r squared I'm going to leave. Now, because I filled in the surface area, I only have one missing variable. So I should be able to rearrange and solve for this missing variable. In order to do that, I'm going to simplify the one side. 12.56 is 4 times 3.14. R squared still stays the same. To get r squared by itself, I'm going to move the 12.56 over, and it becomes division. So going back to our algebra. So 452.4 divided by 12.56 equals r squared. We get 36.0191 equals r squared. Now to get r by itself, I have to square root. So 36.0191, take the square root of that, equals r. And in the end, we get r is equal to basically 6, rounded. So the radius of our sphere that has a surface area of 452.4 centimeters squared is 6 centimeters. For the second question, we're looking at a square-based prism, or a triangular prism. So here, we have a couple things that we need to do. If we look at our shape, we can see that we have multiple shapes here. So we have this triangle, 7 and 24. We have two of them. For the unknown side here, we have one long rectangle that's 7 by 22. We have one triangle that is the base, which is 24 by 22. And we have one other rectangle, which is kind of the ramp part, or the elevated surface, which is 22 by an unknown, or x. So in order to figure out that missing piece, I need to figure out what that slant is, or what the length of that slant is. And in order to do that, if I look at my right angle triangle, I need to use Pythagorean theorem, because I have the two legs and I'm looking for the hypotenuse. So 7 squared plus 24 squared equals c squared. We simplify those two parts, we get 625 equals c squared. Take the square root of that to get c, and we get 25 equals c, or actually let's go back and replace that c with x. So now I know that these two dimensions are 25. Now I have enough information to go through and calculate the surface area, or basically find the area of all these shapes and add them together. So surface area equals 2 times base times height divided by 2, which is the area of my rectangles times 2, because there's two of them, plus length times width, which is the area of my first rectangle, plus length times width, which is the area of my second rectangle, plus length times width, which is the area of my third triangle. So 2 times 7 times 24 divided by 2, plus 7 times 22, plus 24 times 22, plus 25 times 22. Going through and calculating, 168 plus 528. Oh, nope, sorry. Got them mixed up. 154 plus 528 plus 550. Add all these up, and we get that the surface area of this prism is 1,400 meters squared. Moving on to the last shape, again, we can use the formula sheet to figure out the actual formula, which is 2 times width times height plus length times width plus length times height. It may be a little bit easier if we label our sides. So we have our height, we can say our width and our length. But basically, when we break it down to it, what we're actually doing is, if we think about it, we have, let me color code this here. We have two surfaces there, and it's 3 by 2. We have one here and one on the other side. So two surfaces that are 3 by 6. And then lastly, on the sides here, we have two surfaces that are 2 by 6. So that's where this formula comes from. When we plug in our values though, we get 3 times 6 plus 2 times 6 plus 2 times 3, 18 plus 12 plus 6, all multiplied by 2, and then 2 times 36, which equals 72 centimeters squared. So that's it for surface area of 3D shapes. And essentially the surface area for 3D shapes is basically finding the area of all the faces and adding them up. Some of them may be different, like the cone or the sphere when we're dealing with rounded figures. Same with cylinders. But again, you can always refer back to the formula sheet, which does give you a nice formula as well as labels the sides that you have to use. The only difference or the only extra work you might have to do might be where you have to use the Pythagorean theorem to find either the slant height or say a certain measurement on one of the triangular prisms or even one of the square-based pyramids as well. But again, as long as you have those formulas and you understand what shapes you're dealing with, you should be able to reason through it.